All right, tonight we're going to talk about angles and lines, sometimes parallel lines, and we're going to prove these angles are congruent. So the first thing we want to do is talk about vertical angles. And vertical angles are angles that are across from each other, and we've talked about those earlier this year, like angles 1 and 2 would be considered vertical. Angles 3 and 4 would also be considered vertical. So in order to prove that vertical angles are congruent, we just need to prove that one pair of those are congruent. So let's look at some angles. If we take and we make a line, we just trace this blue line right here. I see that angles 1 and 3 together form a pair of vertical or linear angles. So I'm going to say that the measure of angle 1 plus the measure of angle 3 are going to equal 180 because we know that all lines equal 180. And I can also make another line here with this line right here. And I see that those angles that form that line would be angle 2 and angle 3. So I could say the measure of angle 2 plus the measure of angle 3 also equal 180. And we say they equal 180 because they form a line, and we call two angles that form a line linear pairs. So that would be the reason they're linear pairs, and linear pairs make 180 degrees. So the next thing we want to do is we want to look at, we see that we have both of those equal to 180 degrees. So when we have two things equal to the same thing, 180 degrees, we can substitute in. We can say that the measure of angle 1 plus the measure of angle 3 is equal to the same thing as the measure of angle 2 plus the measure of angle 3, because they both equal 180 degrees. And the reason I do that is because I can take this 2 plus 3 and substitute it in for that 180. So that would be called substitution. All right, and as I notice here, I can see that I have the measure of angle 3 on both sides of my statement. So to eliminate that measure of angle 3, all I have to do is subtract the measure of angle 3 from both sides, and I can do that just like we can in an equation. And when I do that, I'm left with the measure of angle 1 is equal to the measure of angle 2, because the measure of angle 3 is eliminated on both the left and the right side. So I did that by subtracting angle 3 from both sides. And I know if angle 1 is equal to angle 2, then they have to be congruent, because that's the definition of congruent. So I could say angle 1 is congruent to angle 2, because the definition of congruence is if they're equal, then they're congruent. So I would say the definition of congruent. So if angle 1 is congruent to angle 2, we have proven that vertical angles are congruent.
Postulate we're going to talk about tonight is the corresponding angle postulate. And I just wanted to show you, I looked up the definition of postulate. A postulate is something that you assume or take for granted. You assert the truth. It is something that is assumed without proof and is generally accepted. So what we're going to do is we're going to talk about the corresponding angle postulate. If two lines are parallel or cut by, if two parallel lines are cut by transversal, then the corresponding angles are congruent. And remember, corresponding is the angles in the same position. And since this is a postulate, we can't necessarily prove it. We have to assume it's true. So I'm going to try to show you with GeoGebra how it's true. And what I'm going to do is I'm going to start by constructing parallel lines. So I'm going to start by constructing a line, and I just hit 2 points. I want to make a line parallel to it, so I'm going to start with another point, and I'm going to draw a line that is parallel, which is my parallel tool, to point C in that line. So I've got two parallel lines. Now, no matter where I go, these lines will always be parallel. Wherever I move them, I've made them so they have to be parallel. So these lines have to be parallel. And another thing that I want to do is I want to make a transversal, and that's just a line that goes through both parallel lines. So I'm going to make a transversal go through A and C. So it touches both of the parallel lines. I'm going to put point E somewhere on my transversal. And I want to make another line so I can have triangles because we've been working with similar triangles. We go through D and B. So I'm going to make another point, and I want it to be at the intersection of both of these lines, so that's point E. So now what I want to do is prove to you that these triangles are similar because that's what we've been working with. So in order to do that, I'm going to use my segment tool, and I'm going to measure how far it is from D to A. And I want to compare that to D to C because they're going to be corresponding sides in the large triangle and the small triangle. I also want to get a measurement from D to B and compare that from D to E because that's another pair of corresponding sides. And if these corresponding sides are proportional and you have the included angle D, we know the triangles are similar by side angle side. So I'm going to use my table over here and I'm going to record my measurements to my spreadsheet so we can compare them. So I'm going to go to my spreadsheet and I'm going to put in segment E here and segment F in the next column. I'm going to put segment G here and segment H here. And I'm going to let it do the work for me. So what I want to do is see if the ratio of these two are the same. So I press equals, and I want to divide E divided by F, and the ratio is going to be 0.55. And I want to see if I get the same ratio here with G and H. So I'm going to say equals G divided by H to get the ratio there. And notice they're equal. And what I wanted to show you is that no matter where I put this line, my triangles will always be similar because my ratios are always going to be the same. No matter how I move it, or how far away, how close, if I move it closer, it still stays the same. So I know my triangles are similar. And if my triangles are similar, then the corresponding angles are going to be similar. So that would tell me that the angles in the same position would have to have the same degrees. So I can use my measuring tool, and I can measure the angle at A. So I'm going to tap B, A, D, and it tells me it's 73.51. And I'm going to measure the angle at C, E, C, A would also be 73.51. And again, no matter how I move the tool, move my shape around, the angles always have to be the same. So we've just proven here with the tool that corresponding angles are going to have to be congruent if they are in similar triangles.
Okay, now we want to try to prove the corresponding angle postulate, which says if two parallel lines are cut by a transversal, then the corresponding angles are congruent. And remember, we said in the previous part that if it's a postulate, we have to assume it's true. But let's see what we can do with some similar triangles. So I'm going to take a line and I'm going to cut another transversal so that I have triangles. I'm going to label my corners A, B, C, D, and E. And we saw in the earlier part with GeoGebra that AB needs to be proportional to BC because when we have parallel lines it does that. And that should be equal to AE over AD. They're proportional sides. We also notice here that we have angle A in both the large triangle and the small triangle, so I could say that angle A is congruent to itself, and the property we use for that is the reflexive property. I always remember that by seeing my reflection in the mirror. It should be the same thing. So that's the reflexive property. And if I have two proportional sides and one pair of congruent angles, I could say that the small triangle, which is triangle ABE, is going to be similar to the larger triangle, which is ACD. And the theorem that allows us to say they're similar is side, angle, side. I've got my two proportional sides in my first statement and my congruent pair of angles in my second statement. And so the last thing is I know if I have similar triangles, then the corresponding angles are going to be congruent in those. So we would say angle 2 is in the lower left, and it's going to be congruent to angle 6, which is in the lower left of the larger triangle, because they're corresponding angles in similar triangles. So if I take away my triangles and I look at my original picture, what I've done is I've stated that angle 2 is similar or congruent to angle 6, and they're both in the upper right hand side on the parallel lines, and they're called corresponding. Okay, our last kind of angles we're going to talk about are alternate interior angles. And alternate interior angles are angles that are inside the parallel lines on different sides. So I would say that angle 3 is an alternate interior angle with angle 6, because one's on the left and one's on the right, and they're in between the parallel lines. I also could say that angle 4 is alternate interior with angle 5, because they're on opposite sides of the transversal. So that's our goal, to prove those angles are congruent. So let's go back with what we know. I know the first theorem we proved tonight was angle 2 and angle 3 are vertical angles. So we could say in our proof that angle 2 is going to be congruent to angle 3 because they are vertical angles, and we've already proven that vertical angles are congruent. All right, next, we also proved that corresponding angles are congruent. So notice that angle 2 and angle 6 are corresponding angles because they're in the same position. So for my next statement, I could say angle 2 is congruent to angle 6. And the reason would be they're corresponding angles, and we've already proven that corresponding angles are congruent when the lines are parallel. So now, if I know that angle 2 is congruent to angle 3, and angle 2 is also congruent to angle 6, I can say in my next statement that angle 3 is going to be congruent to angle 6. Because what I'm doing is taking this angle 3 and I'm substituting it in for that angle 2. So the reason would be substitution. Therefore, since I've proven that angle 3 is congruent to angle 6, I've proven that the alternate interior angles are congruent because 3 and 6 are alternate interior angles.